Hello everyone, I am Dr. Madhavi Kuncham, Associate Professor in the Department of the Chemistry at Marri Laxman Reddy Institute of Technology and Management. Today, I am going to discuss about the battery chemistry, which is the second unit of the engineering chemistry. Now, in that battery chemistry, the very important point is the lithium-ion battery. I am going to tell about the importance and also how it is applicable in the applications, important applications in our daily life. Okay. Now let us start this discussion about the battery chemistry. First of all, what is a battery? Now, a battery, it is an electrochemical cell. Battery is an electrochemical cell. Means, what is an electrochemical cell? Electrochemical cell, it is a device which converts the chemical energy to the electrical energy. So all the batteries are the electrochemical cells which will convert the chemical energy, means whatever the chemical component inserted into that will undergo the chemical reaction and convert into the electrical energy. With that, the power supply will be there in the battery. We can use and with the help of that we can use whatever the devices where batteries are inserted. Okay, so now I would like to explain about that. What are the different types of the batteries? We are available, that is in the market we are available with we are having the number of different types of the battery we are using. And I would like to explain about the different types of the battery what we are using. First of all, batteries are of two types. That is, there are different types, but especially when coming to the electrochemical cells. Here, there are primary battery and the secondary battery. Batteries can be. Generally, we can able to see that usable and the reusable and the recharged and the non-rechargeable battery. Means, rechargeable batteries means we can use in the number of times, but non-rechargeable battery only one time usage. That type we can able to know. When we come, where we are discussing about the chemistry of the battery, we have to go in depth about these types of the battery. Why we are using some batteries, only some batteries we are reusing. That is a number of different types. Means many times why we are using, and some batteries only one time use and throw. So depending upon the chemical component present in that decides whether the batteries can be further recharged, reusable and the batteries can only used in the one time. Okay. Now we'll discuss about the types of the batteries. Coming to the types of the batteries, there are two types. Basically, there are two types of the battery. One is the primary battery and the secondary battery. So what is this primary battery? Primary batteries, now these are the battery. Why they are called as primary battery? The batteries which can be primary batteries, these are also both are electrochemical cells only. Means in which both can convert the chemical energy to the electrical energy, but the electrochemical cell is not reversible chemical reaction. This is primary batteries are the electrochemical cell in which electrochemical reaction is not reversible. And during discharging in the chemical compound are permanently changed and the electrical energy released until the original compounds are completely exhausted. Means here the chemical component which are inserted into the battery they will undergo the reactants. They are called as a reactant. That reactants are converted to the product. Once the reactants are converted to the product, it's over the reaction. It's not possible to reversible reaction. Means the products cannot be converted into the reactant, so that the battery will be considered as completely exhausted. Thus, the cells can be used only once, which can be used only once. And coming to the secondary batteries, these are all the secondary batteries are the electrochemical cells in which the electrochemical reaction is reversible and the original chemical compounds can be reconstituted by the application of electrical potential between the electrodes injecting energy into the cell. Such cells can be discharged and recharged many times. Means, what is this reversible? Reversible means, what I said, that in the electrochemical cell, the chemical components which are called as reactants, when using, these reactants are converted to the product, means chemical reaction will take place. Now, this, once the reactants are converted to the, when the products are formed, and these products, by supplying the external energy, again they are converted to the reactants. That is called as a reversible. And the chemical component can be reconstituted by the application of electrical potential between the electrodes injecting. This is called as reversible reaction. So that is why they can be discharged, again recharged. When the battery is discharged, again by means of supplying the external energy, we can change into that, we can recharge it for the further usage. That is called as a secondary battery. Now, see the cells. Now, see the differences between the primary and the secondary battery. The cell is not rechargeable, that what we have discussed, and the cell become the dead after usage. Means here now see the differences between the primary and the secondary cells. Cell reaction is irreversible, means which cannot be, once the products are formed, over. We need to throw it. It is not possible to convert the product to the reactant. Cell reaction is reversible, means once the reactants are converted to the product by supplying a certain amount of the energy, the products are converting into the reactant. That is called as a reversible. That is why the secondary cells are reversible and must be discarded after usage. Just know what we have said. May be recharged. It can be again further recharged. Have relatively short shelf life. It is having the shelf life of it is very less, very short, and here it is having the longer shelf life for the secondary cells. The function only its function as a galvanic cell, but here it is acting as a both galvanic cell as well as a electrolytic cell, because it is a reversible. So it is acting as a, when converting the reactant to the product is a galvanic cell, and the reactant, when the products are converting to the reactant, it is a electrolytic cell. They cannot be used as a storage devices, and these can be used as the energy can be stored. Now, they cannot be recharged, already we discussed, and some of the example for this is the dry cell, alkaline cell, lithium battery, and the zinc air battery. These are the examples for the primary batteries: zinc air battery, lithium battery, alkaline cells. Whereas coming to the secondary battery, the lead acid storage battery, and the nickel cadmium battery, and the lithium-ion cell battery. These are the examples of the secondary battery. Now coming to the example, that is these are the diagrammatic representation. That is, I want to show what are the batteries we are using in our daily life, what type of the battery they are. Now see, this is a lithium battery. Here it is these are all the primary. Lithium battery is a primary battery. These are all these are the examples for the primary battery, and all these are example for the secondary battery. That is a rechargeable batteries, non-rechargeable, and the rechargeable batteries. These are some of the diagrammatic examples. Now, coming to the lithium battery. What is a lithium battery? Why the lithium plays an important role in the battery chemistry? Here, see, lithium battery, why we have to go for the only, even though we have the number of the metals, why we have to go only for the lithium metal? Lithium is the lightest of the metals, and it can float on the water. This is one of the importance of the lithium. The electrochemical properties of the lithium are excellent, and it is also a highly reactive material. These are highly reactive material. These properties gives lithium the potential to achieve very high energy power. Density, that is a density in the high density battery applications such as automotive and the standby power. This is one of the important advantage for the lithium. Lithium batteries are and now see, lithium batteries are the primary batteries in which lithium metal or lithium compound acts as an anode. Lithium batteries. Now, see, we'll see the differences between the lithium battery and the lithium-ion battery. Lithium battery is a primary battery. Lithium-ion battery is the secondary battery. We'll discuss in detail in the next slide. A lithium cell can produce a voltage from 1.5 to about 3 V based on the types of the materials which are used in that. Now, coming to the types of the lithium-based batteries. Just now we have discussed about the importance of the lithium, why we have to use the lithium as a element in the battery chemistry. Now, in that lithium also, we are having the different types of the lithium-based batteries. In that, we'll discuss about the lithium battery and the lithium-ion battery. There are two types of the lithium-based batteries available here. Now, here, why? What are the two different lithium-based batteries? One is a lithium battery, another is a lithium-ion battery. Lithium, metallic lithium, or the lithium compounds which are used in the battery, lithium-ion battery. In lithium batteries, a pure lithium metallic element is used as an anode. Now see, pure lithium metallic element is used as an anode. These types of batteries are not rechargeable. You keep in mind that here the lithium batteries are non-rechargeable and they are primary batteries. Lithium-ion batteries, when coming to the lithium-ion battery, lithium battery and the lithium-ion battery. Lithium battery is a metallic form and lithium-ion, it is in the ionic form. Lithium compounds are used as an anode in this case, whereas in the lithium battery, lithium metal acts as an anode. In the lithium-ion battery, lithium compounds are used as an anode. Now, these batteries are known as rechargeable batteries. Which batteries? Lithium-ion batteries are rechargeable batteries. Therefore, lithium-ion batteries are considered as best than pure lithium-based batteries. Why they are best? Because they are rechargeable. Lithium-ion batteries are rechargeable, whereas lithium metallic batteries are non-rechargeable batteries. That is the different types of the lithium-based batteries. Now, what exactly is a lithium-ion battery? We are going to discuss. Now, here two or more electrochemical cells electrically connected, interconnected, each of which contain the two electrodes and the electrolyte. Actually, in the starting itself, what I said that batteries are the electrochemical cell. So, what is this electrochemical cell? Electrochemical cell is a device which consisting of electrodes and the electrolyte. So, what are the electrodes? Electrodes are nothing but the anode and the cathode. Anode and the cathode, when dipped into the electrolyte, acts as an electrochemical cell. When the chemical reaction starts, it acts as an electrochemical cell. Now, two electrodes, electrolyte. The redox reaction that occur at these electrodes convert the electrochemical energy into electrical energy. Redox reaction means oxidation at one place and reduction at another place. Oxidation at the anode and the reduction at the cathode will take place. As I said, that two electrodes are used. One is anode and the another is cathode. Now, in detail with the diagram, we'll discuss in the lithium-ion battery which acts as an anode and which is acting as a cathode, how the electrochemical reaction is taking place in the lithium-ion battery. In everyday usage, battery is also used for the reference single cell. These are that why we have to use this one, electrolyte, which is responsible for the conduction of the ions from one electrode to the another. Now, the first modern battery which was invented by the Alessandro Volta in 1800. Alessandro Volta in 1800, the first modern battery was invented. Now, coming to the lithium-ion battery. Lithium-ion batteries, these are, as I said in the earlier, these are the secondary batteries, means that is the reversible batteries. You know about that. Whenever the word secondary battery means it is a reversible, rechargeable batteries you should consider. Now, the battery consisting of anode of the lithium dissolved as an ions into carbon. The cathode material is made up of lithium liberating compounds. typically the 3 electroactive oxide metal. Means the cathode is a electroactive oxide metal. That is material, that is example. One is a lithium cobalt oxide. We can use anything. That is a one is lithium cobalt oxide, lithium manganese oxide, lithium nickel oxide. These are considered as a cathode in the lithium-ion battery. No, lithium-ion batteries are common in the home electronics. We are in our house. Household applications. The many devices are run with the lithium-ion batteries. They are one of the most popular types of the rechargeable battery for portable electronics. It is for the portable electronics with a high energy density, tiny memory effect, low self-discharge. Now, coming to the principle of working, how the lithium-ion batteries works. Under that, in the working of the battery, what principle is involved, we need to discuss. During the charge and the discharge process, lithium ions, this is very, very important. How the charging, what will happen during charging and what will happen during discharging, that we need to discuss under the principle. That means here, lithium ions are inserted or extracted from the interstitial spaces between atomic layers within the active material of the battery. There is a movement of the lithium ion from the cathode to anode, anode to cathode. This movement will generate the electrical energy. Okay. Simply the lithium ion is transfer between anode and the cathode through lithium electrolyte. This transfer of the lithium from anode to cathode, cathode to anode through the electrolyte what we have taken in the battery. Since neither the anode nor the cathode materials are essentially changed, the operation is safe than that of the lithium metal battery. That is why this has advantage over the lithium metal battery, which is a primary battery, and it is a secondary battery. Now, what is a lithium ion cell? This is a construction, how it is constructed. Here is a layer wise, and how it will work. This will discuss under the construction. Now see, secondary cell, it can be recharged. What will be there? As the name suggests, movement of the ions are responsible for charging and the discharging. The charging and the discharging will take place only through the movement of lithium ions. And lithium cobalt oxide acts as an anode. The anode is a lithium cobalt oxide, and the porous carbon graphite acts as a cathode. Porous carbon is a cathode, and the anode is a lithium cobalt oxide. Electrolyte is a polymer gel, acts as a separator between the electrolyte. Now, the separator allows the passage of ions but not the number of electrons. It provides the lightweight, high energy density, and a different source for the devices. Now, coming to the how lithium-ion batteries work. What is the chemistry involved in the lithium-ion battery during discharge as well as during charging? Discharging and the charging. Now, coming to the here, how that during the cell reaction, what type of the cell reaction is taking place during the discharging? Discharging means when the battery is in usage. When the battery is in the usage, the cell, the energy which is there in that going on continuously discharged. So, during discharging, what type of the chemical reactions are involved or what chemistry is involved in the during discharge, that we'll discuss now. During discharging, it acts as a voltaic cell. It acts as a voltaic cell, means how it works. During discharging, the lithium ions flow from the negative electrode to the, now see here, this you can able to see the movement of lithium ions from here, from the anode to the cathode. This is a separator, a polymeric material which acts as a separator. And here it is filled with these two are dipped into the electrolyte. These are the electrolytes are the lithium component, lithium hexafluoride. Hexafluoride is acts as a lithium, that is electrolyte in that, and this is a polymeric material which is used as a separator between the two electrodes. Now, during discharging, the lithium ions, here from the lithium ions, they are moving from the anode to cathode, that is a negative electrode to the positive electrode through the electrolyte as well as the separator. Now the electrons and the lithium ions combine at the positive electrode. They are here this lithium ion electrons will come from through this electrical wire connected there, and the lithium ions will combine with the electron to give the lithium metal and deposited in the form of as a lithium metal. This is a chemical reaction which is involved, which occur during the discharging, right? So during discharge, all the electrons, that is the lithium ions, move from here to here through the separator, through the electrolyte. Lithium ions will move, and the electrons will move through the wire, electrical wire, which is connected to the outside, from the outside to the cathode. Now, coming to the cell reaction during charging. During charging, what will happen? Charging means when the cell is exhausted, means the power has been exhausted, when the cell is no more in the condition to work. This condition is called as it is a discharged. When it is discharged, we need to keep it for the charging. So during charging means what? We are providing the external energy. When provided with the external energy, that what chemistry is involved in the battery will discuss, that is called as a cell reaction during charging. During charging, it acts as an electrolytic cell. It acts as an electrolytic cell in which now what is happening? During charging, the lithium ion flow from the positive electrode. Now here to here, from here to here, the lithium movement of, you can able to see in the diagram. In this diagram, you can able to see that the lithium ions are moving from this positive electrode to the negative electrode, and simultaneously the electrons move from to the wire connected. And these electrons and the lithium combine at this place and deposited as a lithium metal. Okay, negative electrode to the, now see this one, how the lithium ions are moving through the separate, that is electrolyte, and the electrons are moving through this externally through the electrical wire, and finally at anode the lithium combines with the electron and deposited as a lithium metal. So this is a reaction, cell reaction, which takes place during charging. Now see these are the two diagrammatic representation what will happen during discharging and the charging in the lithium ion battery. Now this is a three-dimensional picture of the lithium ion battery, what will happen during charging and the discharging, that is electrometal ion is moved from the layer to layer. There is a layer wise the sheets are there, so that is why it is called as intercalated sheets are there. So here during this, that is the electrons will migrate from the here. Three-dimensional structure of the battery, lithium ion battery. Now at the same time, the compensating electron travel in the external circuit. Just know what I said, that is when the electrons are moving from one electron to other electrode, the electrons, that is lithium ions move from one electron to another electrode. Simultaneously, the electrons move through the external circuit and are accepted by the host to balance the reaction. That is what we have discussed. Now we have seen in the reaction. Okay, now the process is completely reversible. The lithium ions pass back and forth this. Because of this reason, the lithium ion batteries are called as rocking chair swing cell. The typical lithium ion battery can store, this lithium ion battery can store about 150 watt hours of the electricity in 1 kilogram of the battery. This is one of the application that is important. This one, it can able to store 150 watt hours of electricity in 1 kilogram of battery. As compared to lead acid batteries, it can store only the 25 watt hours of electricity in 1 kilogram. That is this lead acid battery is there. When compared to this, here this can store the 150 watts, but whereas it is only 25 watt hours of the electricity. That is application advantage over the lead acid storage battery. Now, all rechargeable batteries suffer from self-discharge when stored or not in use. Now, keep in mind this one, all rechargeable batteries suffer from self-discharge when stored or not in use. But normally there will be a 3 to 5% of self-discharge in lithium-ion battery for 30 days of the storage. This is one of the important. That is the difference between the other batteries and the lithium-ion batteries. Now coming to the advantages of the lithium-ion battery. Lithium-ion batteries they are having the high energy density. They are having high energy density than other rechargeable batteries. Energy density. See, this is one of the application that is important. Advantage means here self-discharge 30 days, whereas they are immediately undergo the self-discharge other. And this is one more. 150 watt is the storage can able to store. That is at 25 watts only. Now coming to here also, they are less weight. They produce high voltage about 4 watts of the as compared with other batteries. They have improved safety. They have improved safety, more resistance to overcharge. No liquid electrolyte means they are immune from the leakage, fast charge and the discharge rate. Now, though having the many different, that is many advantages of the lithium-ion battery, some of the disadvantages also there for this. That is they are expensive. They are highly expensive. They are not available in the standard cell type. Now, applications means where we will come across these type of the lithium-ion batteries. We'll see now. The lithium-ion batteries are used in the cameras. What we will use in the daily calculators, cameras, smartphones, most of the consumer electronic devices. Cameras we daily will use. These are the applications. Calculators, smartphones. They are used in the cardiac, in the medical field also, as a cardiac pacemaker and other implantable devices. These are the application in the medical field. So in the medical field as a cardiac pacemaker and the implantable device in the medicine. Electric vehicles, because of their high, that is a lightweight, lithium-ion batteries are used for the propelling a wide range of electric vehicles. They are used in the wide range of the electrical vehicles such as aircraft, electric cars, pedelecs, hybrid vehicles, advanced electrical wheelchairs. Nowadays, that is electrical wheelchairs also they are using this one. Radio control models, model aircrafts, and the Mars Curiosity rovers. See, in the rovers also it is used. These are the different types of the applications where the lithium-ions, in which the lithium-ions are used. Power tools, lithium-ion batteries are used in the tools such as cordless drills, sanders, saw, and a variety of garden equipment including whippers, nippers, and the head trimmers. These are the different types of the applications where we'll use the lithium-ion batteries. Now, coming to the drawbacks of or the disadvantages of the lithium, already we have discussed some of that is expensive and all. So, we need to discuss some more drawbacks or the disadvantages of the lithium-ion batteries. What is that? It lasts only 2 or 3 years after the manufacturing. Only that is if will not use also, it will discharge after 2 or 3 years. It is sensitive to high temperatures. Means these batteries we cannot use into the devices which run under the high temperature conditions. If the battery is completely discharged, it can no longer be recharged again. Means we should not wait until it is completely discharged. Complete discharge means that means before only we need to charge it. It is relatively expensive. Highly, that is a cost of, because lithium metal it is a cost effective. If the separator gets damaged, the separator the polymeric material what we'll use as separator between the two electrodes gets damaged, it can burn into the flames. We cannot use the battery if the separator is damaged. So these are all These are the importance of the batteries, means lithium ion batteries. That is a first, whenever you discuss about the batteries, you need to understand what are the different types of the batteries, and that is why they are considered as a primary and the secondary batteries. In this session, we have discussed about the types of the batteries, different types of the battery, what are the primary battery, what are the secondary battery, and the examples of the primary battery were discussed, and the examples of the secondary battery. Under the secondary battery, we have discussed in detail about the construction and the working principle of the lithium-ion battery, how it will work, what are the chemical component used, and what are the electrodes, cathode which acts as a cathode in the anode, and what are the cell reaction in that. The cell reaction during charging and the discharging is very, very important. In the next class, we'll discuss about the other, that is a fuel cells, very detailed. Thank you so much.